The James Webb Space Telescope is what's known as a reflector telescope. Two mirrors, one primary and one secondary, used to collect and focus light coming from faraway objects they're looking at. The primary mirror on James Webb is so huge it needs to be assembled from 18 separate mirrors. To find out more about these mirrors and how NASA is making sure they work as well in space as they do on the ground, we've come to the Marshall Space Flight Center in Huntsville, Alabama. We're here with Jeff Cagley, and he's the director of the X-ray and cryogenic facility here at Marshall Space Flight Center. So Jeff, tell us a little bit about where we are and what are you about to see?
Mary, we are in the entry area for our large clean room. These James Webb Space Telescope's mirrors have to stay in a very clean environment, and we have that type of environment here. So we're going to see if we can get a better look at those mirrors. And to do that, we're going to have to get dressed up a little bit so that only our eyes are showing. We're just about to pull the entire test stand assembly into the vacuum chamber with the 3 James Webb mirrors aboard.
I noticed there's just 3 mirrors. Why is that? I think James Webb has 18, right?
Right. The James Webb Telescope is made up of 18 mirrors. We're going to have each one of those mirrors come through here twice. Okay. The first time through, we actually measure the deformation as a function of temperature as we transition down to minus 400 degrees Fahrenheit. Okay. The second time through, we verify that the mirrors actually perform correctly at that temperature.
And you said it's about to go into the chamber. Can we go inside the chamber just to see what it's like and maybe tell us a little bit about the chamber?
Yeah, we'll try to run in there and see if we can beat this transition inside. The mirrors behind us will be pulled in and will actually reside just up in front of us here inside the chamber where they can be cooled to minus 400 degrees.
Why a vacuum chamber?
Well, we have to simulate not only the thermal environment, but also the vacuum environment of space.
You pull these in, and what kind of things are you looking for in the mirrors?
Well, the Ball Aerospace team is actually responsible for the testing, and they will actually be looking at these mirrors as they transition to a cryogenic temperature through a window up in the front of our vacuum chamber. And they'll be looking at these mirrors with an instrument called an interferometer. And that's going to give them a very detailed surface map of what that mirror looks like and how it deforms as a function of temperature.
And my last question is, why is it so important to be so precise with these mirrors?
Well, the primary mirror for a telescope is the part of the telescope that really matters. It's gathering all the light that ultimately gets focused on the instrument. And the larger and the better the mirrors are, the better the telescope is.
These mirrors will be in the vacuum chamber for about 15 weeks, going through 7 cycles of temperature changes from room temperature to the cold extreme of space, 414 degrees below zero. Thanks again for joining us behind the Web.